we're going to go over how the scientists can find out the wavelength or the frequency in a wave, or also the energy in a wave. And so there's two different formulas you're going to use. The first formula is C, which stands for the speed of light, and that is a constant, which is 3.00 times 10 to the 8 meters per second. That is a constant that you will be given every time. And that's going to equal the wavelength, which we said was the lambda sign, and the unit is a meter, times the frequency, which is symbol is a V, and a unit is 1 over a second, or sometimes you'll see Hz, which stands for hertz. Now, when we're doing these problems, like on page 21 in your book, number 1, it says, what is the frequency of green light, which has a wavelength of 4.90 times 10 to the negative 7 meters? So we use our formula. We've got C equals wavelength times frequency. We know what C is. It's 3.00 times 10 to the 8 meters per second. And it just gave us the gave us the wavelength, which is 4.90 times 10 to the minus 7 meters. Okay? And it's asking me for the frequency. So the variable we don't know is V. So you plug in the numbers you know. You got the variable you don't know. So how do I solve that? You divide both sides, okay, by the wavelength. And that gets rid of it on this side. And then I'm left with 3.00 times 10 to the 8 divided by 4.90 times 10 to the minus 7. And that will equal my frequency. All right? Now, when you do that, okay, if you're going to be using one of these kind of calculators, you have to use your exponent button. So I'm going to type in 3.00 exponent 8 divided by 4.90 exponent negative 7, okay? And so my answer is 6.122 times 10 to the 14th. And then what is the unit for frequency? It's 1 over S, or a hertz. That's not a 5, that's 1 over S. Okay, and that would be my answer. It's very important that you understand how to type it in your calculator. If you have an exponent button, that stands for times 10 to the. Okay, it's either going to be an EXP, an EE button, usually on a calculator. Okay, how to do this, or how to type it in your calculator. Okay, so you're going to type in 3, so do it with me. At your desk, do it with me. 3.00, then hit your exponent button, which on the TIs is an EE, on the Casio is an EXP. So you just hit that button, and then hit 8, because that's your exponent, divided by 4.90 exponent button, negative 7. You should get that answer. All right, we're going to do another one. It says an X-ray has a wavelength of 1.15 times 10 to the minus 10 meters. What is the frequency? So once again, we're looking for frequency. We're starting off, this is our formula, right? We know what C is. It's 3.00 times 10 to the 8 meters per second every time, because that's a constant. It gave me the wavelength of 1.15 times 10 to the negative 10 meters. All right, so how do we solve for V? Divide, you got to get it on top by itself. Well, it's already on top. It needs to be by itself, so divide both sides by 1.15 times 10 to the minus 10. 1.15 times 10 to the minus 10. That gets it off of this side. Okay, and then when you do it, you type in your calculator, just like we just talked about, 3.00 exponent 8 divided by 1.15 exponent negative 10. And you should have gotten your frequency equals 2.61 times 10 to the 18th, 1 over a second. The unit. All right, now the third question says, what is the speed of an electromagnetic wave that has a frequency of 7.8 times 10 to the 6 hertz? You say, well, wait a minute, speed? I thought that was a constant. It is a constant. So what is the speed of any particle or any wave? 3.0 times 10 to the 8 meters per second. So you're not actually doing a problem there. If it asks you the speed of a particle or a wave, that is the speed of a particle or a wave every time. Okay? So anytime it asks you for the speed, you know the speed. It's a constant. All right? Now, what about the energy of a wave? Okay? We said before that frequency and energy go hand in hand. You increase the frequency, you increase the energy of a wave. All right? Now, when you're doing problems with energy, you're going to use the formula E, which stands for energy, which is measured in joules, capital J is the symbol, equals Planck's constant, the symbol is an H, and that is Planck's constant. That is also a constant that you get every time, times the frequency again. All right? And the frequency is 1 over an S, or a hertz. All right? So let's look at page 124, number 5A. It says, what is the energy of a wave, okay, that has a, it says, what is the energy of each type of the following radiation? And it gives you 6.32 times 10 to the 20th S minus 1, which is the same as 1 over S. It's giving me the frequency. So I'm using my formula. E equals HV, okay? E equals Planck's constant, so that's 6.626 times 10 to the minus 34 joules times a second times the frequency. And the frequency it gave me was 6.32 times 10 to the minus, times 10 to the 20th, and 1 over a second. So all I'm doing on these, it's easy, right? I don't have to multiply, divide, get it on the other side. It's already good. So I just multiply those two numbers. But can you punch that in your calculator? That is the key. 6.626 exponent negative 34 times 6.32 exponent 20. And your energy for that for that radiation is 4.188 times 10 to the negative 13, and it's joule is the unit. Okay? You guys see that? So if it gives me the frequency, all I do is times that by Planck's constant to get the energy. I will do one more. What if they give you the frequency is 9.5 times 10 to the 13? Okay, well, use my formula, energy equals HV. You need to write the formula every time. That shows me, hey, I know where I'm going. That way, if you make a mistake in your math on your calculator, you still get partial credit. So energy equals Planck's constant, 6.626 times 10 to the negative 34 joules per second, times the frequency it gave me, which is 9.50 times 10 to the 13 hertz, HZ. All right, so take those two numbers, punch them in your calculator, 6.626 exponent negative 34 times 9.50 exponent 13, and the energy of that wave is 6.295 times 10 to the negative 20, and it's a joule, J. All right? Now the key is this, okay? I know how to do these problems, okay? You need to practice your problems and make sure you need to practice and punch it in your calculator. Make sure that you can do that. Make sure you know how to use exponents on your calculator, because every calculator is kind of different in what button you use for exponents. And you do not punch in 3.00 times 10 to the exponent button. The exponent button stands for times 10. That's why it's there. Okay? All right, so that's how you do energy problems and frequency and wavelength problems in the class. All right, shut it down.